classical scale universe of our daily lives is emergent. It emerges from the continual interactions of countless myriads of individual elementary particles. This means the actual elemental data of the computational universe is just the data of elementary particles that's continually updated by their interactions, and the enormous richness and variety of all the complex particle structures we see around us are relationships among groups of particle data viewed in aggregate. All compound structures in the universe are emergent. We are the emergent structures of our elementary particles, and everything else is the emergent structure of its elementary particles. So everything above the elementary particle level is emergent. In particular, dimensional space-time is an emergent structure created by particle interactions as explained in Deep Reality Talks 2 and 3. In a computational universe, emergence means that the data of emergent structures isn't independently stored. The only data that's actually stored is the data of elementary particles and their particle components. Emergent structures are the data relationships that emerge from groups of particle data viewed in aggregate. They can't even be recognized except by other emergent structures, including human observers. Emergence can be easily understood by an example. Assume the universe is a vast 3D TV screen, and the colored pixels are the actual stored data of the elementary particles. And assume these pixels continually interact according to the laws of the complete fine-tuning that govern the universe. Over time, the continual interaction of all the pixels on the screen will gradually produce the entire universe of stars, planets, inanimate objects, and eventually life. Humans will evolve and to begin to live out their lives on the screen. But all the while, the only actual data was always just the individual pixels on the screen. All the compound structures existed only as forms produced by the pixels. And these emergent forms are visible only to observers able to view groups of pixels in a meaningful way. The information is all there, but it's only stored in the individual particle data. Thus, the combined data of all the individual particles is the data of the entire observable universe, including its emergent structures. So our TV shows the entire history of the universe, but only an observer able to see the relationships among the pixels will be able to make sense of it. All the individual pixels are just blindly interacting with their neighbors, according to the rules of the complete fine-tuning, and have no idea at all of what countless myriads of them are doing in aggregate. This is how emergence works. The universe continually recomputes its complete data structure, but only at the individual particle level. Out of these computations emerges the complexity of the entire universe based on the extremely simple but incredibly profound rules of the complete fine-tuning. The universe consists only of the individual data of elementary particles, but over evolutionary timescales, this computes the entire emergent complexity of the observable universe. Now, the great beauty of this model is that it enormously simplifies the design of the universe, because now only a single elemental program that computes individual particle interactions is sufficient to create the entire universe. So all the enormously complex equations of science are just descriptions of the universe at the emergent scale, but don't actually compute it. Thus, the computational logic and math of the universe becomes enormously simpler than the human math and science that describes it at the emergent scale. The elemental program that computes the entire universe is relatively quite simple. This means there are major differences between human math and reality math. Reality math is just the relatively simple logic and math needed to compute particle interactions. Human math discovers and generalizes the basics and then explores their nearly inexhaustible implications, but these have no necessary connection to the actual logic and math of the computational universe. In particular, infinities and infinitesimals aren't necessary to compute particle interactions in a finite universe with a minimum granular scale. Other differences are explored in my book, Universal Reality 2.0. Thus, the actual computational universe becomes much simpler, and the great complexity of the universe of science is mainly descriptions of its emergent structures rather than the computations that compute it. Much of this complexity arises in the manner in which particle interactions create space-time. Another important implication of the design of the computational universe is that it must be logically consistent and logically complete. If a computational universe produced logical inconsistencies, it would tear itself apart, and if it were logically incomplete, it would pause in its computations and cease to exist. But the computations are like those of a typical computer program in this respect. They always produce a consistent subsequent state from the previous state, and all states throughout the entire history of the universe are always logically and mathematically consistent, because the axioms of the complete fine-tuning are consistent. So unlike human mathematical systems, Gödel's incompleteness theorem doesn't apply to reality math or to the computational universe. The computational universe is completely consistent and logically complete. And this has important implications for the nature of the complete fine-tuning that underlies it. Computational systems must be based in a set of consistent logical rules. We can call the complete rules necessary to compute the entire observable universe the complete fine-tuning. The complete fine-tuning is all the virtual data necessary to compute the entire universe. This includes the elemental structures such as what particle components exist and which combinations form valid particles, the elemental constants like the speed of light and the charge strengths, and the logic and data manipulation operators used by the elemental program. The elemental program uses the operators, constants, and structures to encode the logical mathematical rules used to compute all particle interactions. The rules that compute the entire universe must exist somewhere as virtual data. The realm of virtual data is the quantum vacuum, so all the virtual data of the complete fine-tuning exists within the quantum vacuum, which is the realm of all virtual data. Now the entire observable universe of actualized particles emerges from the quantum vacuum and depends upon the virtual data of the quantum vacuum to maintain its existence. So it makes sense to think that the entire observable universe also exists within the quantum vacuum as its actualized data. In this view, the quantum vacuum is all that exists. It contains two realms, the realm of the virtual data of the complete fine-tuning and the realm of the actualized data of the observable universe that the virtual data computes. The observable universe consists of the actualized data of the elementary particles and particle components and the implicit interrelationships produced by their computational interactions that are the emergent structures of the universe. This is the design of the entire universe of the quantum vacuum in a nutshell. Now, the virtual data of the complete fine-tuning is observable only through its effects on the observable data. And the observable data of the observable universe is observable in the sense that its processes can interact. This is because all observations are interactions, and all interactions can be considered generic observations. So to properly understand the emergent universe and how it works, we need to understand what the elemental data is, how it's computed, and the nature of the emergent universe that emerges from its interactions. First, the particle components that form particles are the elemental data of the universe rather than the particles themselves. The reason is that particles often transform into other particles when they interact, but the amounts of their particle components are always conserved with only a couple of rare exceptions. The particle components that make up elementary particles are identity, for example baryon and lepton numbers, mass and the other force charges, spin, spatial and temporal parity, and a few others. Putting these particle components together in the right combination forms all known particles, and in every particle interaction, these particle components are conserved rather than the particles themselves. Thus they are clearly more elemental than the particles they form. So the particle components are the elemental data types from which the entire universe is constructed. They are the little data bits of reality. We must also add the numeric positions and velocity of particles in computational space to the elemental particle data, as these are necessary to conserve total mass energy in all particle interactions and to distinguish among particles of the same type. It's these relative positions and velocities of particles that in aggregate our brains simulate as dimensional space-time. Now, the main determinant of how particles interact is the conservation of their particle components, including mass energy, and the balance of the four fundamental forces that determine their binding energies. These are set in the complete fine-tuning and determine the emergent structure of the universe. The best example is how the balance of electromagnetic force strength and the conservation of energy determine how atoms and molecules are formed. Electrons and protons are attracted to each other due to their equal and opposite charges. They want to combine to form neutrons, but they usually can't because energy must be conserved in all particle interactions, and the combined mass of a proton plus electron is less than that of a neutron. So a large amount of additional energy is necessary to form neutrons, and this is usually only available in the extreme gravitational forces of neutron stars or black holes. So without additional energy, electrons fall towards protons, but they can't combine and they can't escape either. As a result, electrons are trapped in specific harmonic standing waves around protons called orbitals, depending on their energy. Electron orbitals are all the possible harmonic standing waves electrons can form around protons. It's quite simple, and how these orbitals are filled produces all the possible different atoms and molecules that determine the entire structure of the universe. Each different harmonic wave has a different energy, and this is why electrons have quantized energies in atoms, which led to quantum theory and is also the source of their spectral lines. So only the relatively fine-tuned relative masses of protons, electrons, and neutrons permit all the matter in the universe to exist. Only very slight differences in these masses would make atomic matter and the entire universe impossible. This is only one example of the exquisite tuning of the complete fine-tuning. Now, a fairly small set of similar rules determines the packing of protons and nuclei by the strong force and the other fundamental rules of particle interactions that create all the emergent structures in the universe. And these rules are all encoded in the elemental program that computes all particle interactions. So emergent structures include all the compound data structures above the elementary particle level. Elementary particles emerge from particle components, compound particles from elementary particles, atoms from compound particles, molecules from atoms, chemicals from molecules, and materials from chemicals. So all the incredibly complex structures of geology, planets, stars, galaxies, and the entire observable universe, including the biological structures of life and ourselves, emerges from the simple rules of the complete fine-tuning. But this entire universal structure is actually computed in the form of a single, highly connected universal entanglement network, which is the emergent structure containing all implicit relationships among all the particles in the universe. Now, when examined more closely, this entanglement network takes the form of computational domains. Domains are fuzzy, hierarchical, overlapping areas within the entanglement network distinguished by computational similarity, density, or relative action and motion. So domains are distinguishable emergent areas within the entanglement network, but aren't completely discrete independent entities, since the entire entanglement network is strongly connected through particle interactions. Now, humans and other species base the discrete things we think in terms of on these naturally occurring domains in an ad hoc manner depending on the task at hand. For example, an ocean is a single body of water characterized by myriads of overlapping domains of currents, tides, waves, and ripples. However, surfers see the ocean in terms of individual waves, oceanographers in terms of currents, and smelt in terms of tides. This is how living programs base the discrete things in their simulations on naturally occurring computational domains in the entanglement network. Another example is the domain of a forest, which consists of myriads of overlapping domains of trees, species, branches, twigs, leaves, etc., any of which could be considered a discrete individual thing by humans depending on current interests. So how humans use things and the logic of things to compute their simulations of reality is described in more detail in my books. Now, domains and things can be categorized as inanimate or animate. Humans and all other living beings are examples of animate emergent processes. But emergence holds at all levels, so the great sweeps of cosmology, evolution, and human history are all emergent processes, and no doubt there are many emergent processes far beyond the limited comprehension of our human brains. So there's an immense overlapping hierarchy of processes continually recomputing their domains from the subdomains that compose them. Human history is the aggregate computational effect of the actions of all individual humans over time, and the evolution of Earth is the aggregate computational effect of the continual interactions of all its individual particles over 4.5 billion years. Now, each emergent process can be considered an emergent program that continually recomputes its data structure in interaction with the other programs that make up its computational environment. And in interaction, all the programs in the universe compute the entire evolution of the universe. This is a valid way to consider the emergent universe, so long as we remember that programs are based on overlapping hierarchies of intrinsically fuzzy domains and are always somewhat arbitrary. Emergent programs are programs in the same sense as computer programs. Like computer programs, the only actual computations are those of the elemental operations. The high-level program is the emergent effect of the organized sequences of all the elemental computations in aggregate. So the important takeaway is that emergent programs and data structures are just ways of viewing a single universal entanglement network in terms of individual things and processes. So it's important to understand the structure and implications of the entanglement network from the point of view of information cosmology. It's useful to define forms as meaningful units of data or information. The word form emphasizes structure, whereas information emphasizes content, but structure and content are identical when it comes to information. So basically, data is the raw data of the universe, whereas forms connote units of data meaningful to some observer or process. In this view, the universe consists entirely of forms. Individual forms continually emerge, transform, split, combine, and dissolve into other forms, depending on their computational interactions with the other forms that constitute their computational environments. Now, forms continually interact with other forms, and these interactions alter the interacting forms. An interaction is always an alteration of some sort to a form. The alteration of a form by an interaction is the form's experience of that interaction. So all interactions of forms can be considered generic experiences. In particular, all forms carry information about other forms they've interacted with in the alterations produced by those interactions. Living programs have evolved to augment generic experience by developing specialized data structures that alter in response to interactions with other forms in a manner that represents knowledge of those other forms. These specialized data structures are the simulations by which living programs model themselves within their environments to facilitate their functioning. Living programs are characterized by having internal simulation models of their environments. The human mind is a simulation. The simulation will be explored in the next Deep Reality Talk number 7. The alteration of forms in the simulation is the essence of knowledge, because it encodes information about the forms that produce the alterations. And in this universe, the transmission of information by forms about other forms is incredibly rich. The Sherlock Holmes principle is the communication of information about non-present forms by proximate forms. The Sherlock Holmes principle is the basis of all knowledge, including scientific and forensic knowledge. A great example of this incredible richness is the spectra that enable us to deduce the chemical composition of both near and distant objects simply from the forms of light they emit or absorb. Now, the manner in which individual forms evolve is governed by the general principle of evolution. Forms that are computationally adaptive in interactions with other forms tend to resist change and persist. So the Darwinian principle of evolution is simply a special case of this general principle that applies to individuals of species that tend to propagate their kind. Another important point of information cosmology is since all forms experience each other in their interactions, the universe can be said to consist entirely of generic observers continually observing each other. And in this sense, the universe observes or experiences itself into existence and becomes aware of itself through the continual interaction of its forms. And it becomes consciously aware of itself through the experience of the living programs it creates. In this way, deep reality incorporates the concept of observer into its fundamental structure. Another important consequence of information cosmology is that once the past has been computed, it's completely fixed and can never be changed, not even the slightest detail. The precise, actual results of every quantum process were completely fixed as they were computed. So the entire logical structure of the past history of the universe is now completely exact and determined down to the minutest detail. It can't be changed in any way whatsoever. By contrast, the future hasn't yet been computed, so its possibilities are probabilistic. And the present is the current moment in which the actual observable universe is being computed from its previous exact fixed data state. This means the universe is not a causal structure. Causality applies to a physical universe, not to a computational universe. Adding 2 plus 2 doesn't cause 4, it computes it. So the entire past universe is an exact and consistent computational structure, not a causal structure. In particular, this applies to the exact structure of the complete fine-tuning. That's the original data structure of the universe. This means there is simply no possibility whatsoever of any other complete fine-tuning than the one that's existed since the Big Bang. The current actual data state of the entire history of the computational universe that was computed from the complete fine-tuning completely falsifies even the possibility of any other complete fine-tuning. In addition, the complete fine-tuning exists because it, and perhaps only it, can produce a logically consistent and complete computational universe, which is absolutely required for the universe to exist. For a computational system to be consistent, its axioms must be consistent. Certainly, many of the details of the complete fine-tuning are necessary for consistency, such as its precise logico-mathematical structure. So this is the solution to the supposed anthropic problem. Why do we live in a universe with a complete fine-tuning that makes it just right for intelligent life? The answer is that any other complete fine-tuning is simply impossible. That's all there is to it. The fact that we can imagine other possible complete fine-tunings in no way implies they must exist or have actually formed complete other universes. This is an incredible fallacy and the height of irrationality, and it's the ultimate in non-parsimony to imagine that because we can't yet explain a small set of values, that myriads of entire other universes pop up to include all other values. And since this is the reason for most of the speculation about multiple universes, there just isn't any valid reason to think multiple pocket bubble or multiverses actually exist. In Faced with the problem of why something is the way it is, the rational approach is to solve the problem, not to imagine Googles of other possible universes suddenly appear. Now, if there are big bounces as proposed in Deep Reality 5, each stochastically evolves a new emergent universe that's a new variation on a fundamental plan implicit in the complete fine-tuning since the beginning. While the basic principles remain the same, the details will vary widely, depending on the quantum randomness that continually tweaks the progress of evolution. So emergence can play out in many different random ways within the overall plan. However, in each universe, emergence tends to converge towards basic end states hidden implicitly within the complete fine-tuning, such as the evolution of life and eventually some form of intelligent life. This is the principle of convergent emergence, though the particulars depend on myriads of random quantum events. These are the greatest questions. Does the universe somehow evolve towards a state of increasing self-awareness by creating more and more sentient beings as organs to become aware and conscious of itself? Or does it evolve in some other unforeseen direction? One might like to think it ultimately evolves towards a design of increasing universal sentience and compassion, but the evidence for that remains unknown. One last consideration is the possibility that the particular data evolution of each successive big bounce somehow feeds back to tweak the complete fine-tuning of the next one. And in this way, could successive big bounce universes gradually evolve towards some ultimate unknown end? This concludes our Deep Reality talk on emergence and information cosmology. Much more is to be found in my book, Universal Reality 2.0. Stay tuned for the next Deep Reality talk on the real simulation, and subscribe to stay informed.